Hello, I'm going to demonstrate swapping between two arguments in C++. When we're swapping between different data types, we're doing function overloading. And I wrote this program called myswap.cpp. So I'm on this Linux machine right now, which I'm going to just basically, if I do a uname minus, uname minus P for platform or uname minus M for machine type, it shows x86-64. And then this is on Ubuntu Linux OS-release. It's Linux Mint 19.3. If I just look at the processor, speed cut proc CPU info, and then cut proc CPU info. Yeah, somehow whatever I typed earlier, I must have typed in one character off. So this one, it shows that it's an AMD processor here. The type of the processor I have. So earlier on another session, when I say this machine type is x64 AMD processor, I wanted to show you that, yeah, I knew that information, but I didn't show on the video that is the type of processor. So I could also see, like, look at the model, -I model, and then just says model name is AMD-A something, right? So I know that I'm running on that architecture, which means my code is going to be compiled for this platform later on. So I'm going to open up Vim and myswap.cpp program. And as you can see, if I just set my line number, set NU, on the Vim editorial, I press escape shift colon, and then once I type in on the colon, I'm on the editorial, the command that I pass in, say, show the line numbers. So I can see the line numbers there. And then inside here, basically, I'm looking at my program from line 1 through 9. 9 is multi-line comments. And comments are ignored by the compiler, and they're just there for readability purpose. So for this program, on line 3, I have the program name myswap.c++, the description. This one is demonstrating the function overloading using one function, namely swap, but passing different argument with different data types. So the number of arguments is, in this case, is not changing, but what function overloading, you can either change the number of arguments or the data type of the argument. That's what a function overloading means in C++ object-oriented programming. But the name of the function remains the same. In this case, the function is called swap, and whether I pass the char characters, ch1 and ch2, or int x and y, as integer, or Boolean b and 1, or a double d1 and d2, or string s1 and s2. The data types are different, but notice that for each of those two variable, I'm passing it by reference. So these the ampersand that are used here or for showing that I'm passing it by reference. So whatever change happened on those variables at the time of swapping, I want to see the changes. That's why we're not passing it by value. We're passing it by reference. So here, the function starts up with line 11, including the two directives called include, line 11 and 12. One of them is going to include the IO input-output stream, and the other one is the string library. On these two libraries are essential for my programs to work, and then some of these cout, for example, cout object and endline object in a string class, they are defined, the string is defined on this string library, and then the cout and cn are part of the IO stream, but they are object of a standard name resolution. So the conflicting of names will be resolved because the std standard library. So here we're doing function prototyping or function definition. Each time I prototype it, the function swap is the same name, but have different data type. The data type that are passed on, char1, ch1, and ch2, or passed by reference again. And then here on the line 24, we're passing, we're prototyping a function. Prototype or declaration is the same word. So here we're declaring it or prototyping it. Before we use it, inside main, we have to declare them. And then normally you declare them by giving the return type, the function name, the data type that it takes as arguments, the number of arguments, and then a semicolon at the end of it. And then when you actually define it, you take the semicolon out and you just pass it on, and then start the brace and end brace, and then between the function definition, you actually define it. But here, all we're doing is defining it. So, and the function definition, or I'm sorry, all we are doing is prototyping it or declaring it. We're not defining it. We're declaring it and also prototyping it, the same word. So when you do prototype or declaration, you actually don't need to have the variable name. All you need is the data type and then on the ampersand if you're passing by reference. But when you're actually defining it, then you need to pass on the function names, the arguments of the function as well. So here we're doing the function main. It returns an integer because the line, let's see what line is that, 83, we're returning a 0, meaning successful. When the program completes normally, it returns 0, meaning that everything went fine. If the program returns a non-zero number, a negative number, or anything else, then something went wrong. So the int main does not take any argument. In this case, C and C++ is like void. That means that we're not passing on like argc or char double pointer argb. We're just passing it void, and then if you're just doing void in C++, you don't have to write void inside the main parameters. So C requires it, but C++ doesn't. So char, these data type that I'm declaring is character L for my last name and character W for my first name. And then the integer 5 and 10, we're defining it in Boolean true and false, B1 and B2. And D1 and D2 takes two doubles, and then a string 1 is 1 and is 2, or my first name Wahidullah, and a string 2 is last name Lutfy. So in this case, so I'm going to swap all of those ones using the function swap. And here on line 56, I'm making a call to the function swap, but passing two characters that are defined here, ch1 and ch2. So this function 56, it makes a call to the swap, but passing L and W, L for ch1 and W for ch2. Similarly for x and y, this function is called, but notice the parameters are different, x and y this time rather than character, and they are defined as integer 5 and 10. And so a Boolean true and false. And so double 25 and 15, 15 and 25, 15.5 and 25.5. And same thing with the string 1 as Wahidullah, my first name, and a string 2 as Lutfy is passed down. Then the actual swapping are happening at each function definition. So the function definition, as you can see, it has everything that the function prototype had, and instead of the semicolon, we are actually starting a brace and ending a brace and defining the function. So the function definition for the first one, let's start at line 89 till 96. And all we are doing is that we're writing the character that we read inside the function, and then we swap them by using another temporary variable, which is also data type of character. In this case, because swap other two parameters or character, so we're swapping the two characters. ch1 gets assigned to temp, ch2 assigned to ch1, then temp that stored the value of ch1 is put back to ch2. Now that is swapped. Similarly for int x and y, and as long as we are passing it by reference, the swapping will be just stored properly. Otherwise, we may, once the scope of that function is done, if we pass it by value, we will lose the value. We're going to have same value that we had previously. So I just did the same thing for a string and then for the double. As you can see, nothing else, is just the data type changes. The swapping is similarly done. So I'm going to save this one, and then I'm going to just compile it and say G++ minus O myswap.c++. Actually, myswap.nothing, because I just want to pass on the swap.c++. This is saying that minus O is saying that create an executable file out of this source file. So that's minus O compile this myswap.c++ and also run the loader to link the preprocessor and object file and executable file with the shared library, dynamic library, and create this file as the final executable. Since the $? Returns 0, meaning that main return 0 successfully compiled. It had no syntax error, no semantic. Semantic will just show up at the runtime. So if I just say, now what type of this file this is, my swap is executable. You can see executable link format, link format 64-bit, and it's for x86 64 processor, as earlier I pointed out to the AMD processor of uname -M for machine type, or uname -P for a platform, x86. So we are going to just now, what I'm saying here is important, because if you are taking this one and executable, you just want to run it on another AMD x86 64 processor, you don't need anything. It just compile, it runs on that same platform because it is built for that processor. But if you take this one and maybe the source code that I have, you want to just compile it on a Spark or another or AMD, or I'm sorry, not AMD, or another processor of maybe some other architecture, whether it's Apple or Sun Microsystem Spark or something else, then you have to compile it again. And then by putting this GW G++ minus O, it will just -O is going to create this executable file based on the architecture of the machine and the processors and the proper preprocessor included, and also the shared object files get dynamically linked with it. So at this time, the program ran and successfully. All I want to do is run it to see if it does what we were asking for it. So when I run it with /myswap, and then you can see that the characters were these, and then inside the swap function was there, and then after the swapping, it changed. Character 1 become W and character 2 become L. So the swap is done. Here, similarly for integer, and then after swapping, the value becomes 10 and 5 when it was 5 and 10. Similarly, for Booleans, the original one, B1 was true meaning 1, and B2 is 0, meaning false. So inside was the same, and then after the function swap was called, then it swapped, B1 become false and B2 become true. And then similarly for the double, you can see it worked for that one, and similarly for string. So string 1 had Wahidullah, my first name, and string 2 had last name Lutfy. So inside the swap function, it was the same, but then after the swapping is done, string 1 becomes Lutfy, my last name, and string 2 become my first name, Wahidullah. And I just want to also point out one more thing, that if I do a ls minus ld, my swap and my swap.c++, you can see the two files. One of them is source code, which is read, write, and then dash, meaning that the owner, W. Lutfy, has read and write access. But because this is just a source code, you're not compiling it, there's no executable bit set for that one. And that is based on the UMask of the system. So UMask is 002. A file, when it gets created, it is actually 777. So 7 minus this would be read, write, and then actually for the file is 666, and then for the directory is 777. So since it's a file 666, 6 minus 0, this is read, write, because it's 2 to the power of 0 to the power of 1 to the power of 2. So 2 to the power of 0 is 0, and then 2 to the power of 1 is 2, and 2 to the power of 2 is 4. 2 plus 4 is 6. So that is read, write. And then the first one. The second one is also read, write, but the last one is 6 minus 2 is 2. 6 minus 2 is 4. So this one is 2 to the power of 0, to the power of 1, and to the power of 2. To the power of 2 is 4. So that's why this is a read, write, is bit is set. If a bit is off, is dash, meaning that that is not allowing it. So in this case, the file is also showing as executable. And if I type in my swap itself, you can see it's executable link format. So Linux mark it as green here, saying that it's also the execution permission is there, set there. And then the other option for this file, it is just my swap.c++ is a source code ASCII text. And if I look at the content of that file, cat minus swap.c++, type more, I could see one screen at a time by typing it more, and the minus n shows line numbers. So this is the entire code here. And I'm going to stop here. I hope you enjoyed it. And if you have any question or any comment, please make your question or comments at the website. Thank you so much. Have a nice one.